Hi. If you want to understand how reinforcement learning actually works, then you have come to the right place. Because in this interactive tutorial, you are going to learn this wonderful machine learning technique step by step by doing it. Before we dive into the details, let's try out some interesting navigation problems to become familiar with the interface and how to use it. This simple environment consists of four states S1, S2, S3, and Sx. We want the robot, machine, also called an agent, to learn to reach to destination Sx from any other state. However, the agent must follow some constraints. It can go to destination only from S3. From destination, it can go to any other state. From S1 it can go to S2 and S3. From S2 it can go to S1 and S3. And from S3 it can go to Sx, S2 and S3. If the agent follows any of the above actions, the environment will reward the agent with, let's say, 1. Notice that the direction of the edges is showing a positive reward. Any other action will be given 0 reward, even though the agent can move from S1 to Sx, but the reward for that action is 0. As we add or remove these constraints, the rewards are updated in a table accordingly. You can verify the navigation constraints information in the rewards table, which is given on the right hand side of the tutorial. For example, let's check the reward for going from Sx to S1. It's 1. How about S1 to Sx? It's 0. Given the constraints, it's clear that agent cannot use only rewards table to learn to navigate this simple problem. For example, from S1, choosing the maximum reward, agent can go to S3 and S2 equally likely. So it will never end up to Sx. However, if agent follows 3 reinforcement learning steps enough number of times, then it can learn to navigate with not only in this problem, but any other problem formulated like this one. Let's test how our agent is learning this simple task. If we click on the Run button, the agent will start learning by following the reinforcement learning steps. It will continue repeating these steps for 1000 iterations, and we will end up learning the best way possible to reaching to the destination. In each iteration, agent is starting from a random state and trying to learn the quality of actions, the best way possible to reach to the destination. If you want to see what agent has learned, then click on the solution button and choose the state where agent should start. Let's say we test S1. In the graph, you can see the path that agent selected to go to the destination. It is marked by green edges. If we select S2, the path is from S2 to S3 and then Sx. And if we choose Sx, for S3 it is like this, and for Sx, notice that Sx being destination, agent has learned that if Sx is the starting state, then it will stay in the same state. And you can see that agent is navigating to destination without any mistake. Let's try a few more interesting problems before discussing what actually is happening behind the scenes. So in this problem, we have 6 states, and only S2 and S1 are the states that allow access to the destination. So if we let the agent run and learn this problem, we expect that agent, if starting from S5, shall not go to Sx directly, but it will go to S3 and S2 and then to Sx. So we let the agent run for enough number of times and learn this constraints from the rewards table. So for S1, agent is taking this path. For S5, agent is taking this path, which is as expected. For S4, agent is taking this path. Let's look at this problem with more states. We have 8 states now, and only state 2 and state 1 are giving access to SX. So starting from any other state, we cannot have direct access to the destination state SX. If we let the agent run and learn enough number of times, then we expect that agent will be able to follow these constraints and find the destination in this problem. So let's test what the agent has learned. We can check state 4 being the starting state, and we see that agent has learned to go to the destination through the correct path. For S7, the path looks like this, which is the correct one. Agent could go from S2 to S1, which is allowed and rewarded, but since this being the better path, shorter path, so agent learned to take a turn from S2 to destination directly. Let's look at another problem drawn in this interactive tutorial. Right now we have 9 states, and the only state giving access to the destination is S1. That means from any other given state, if agent starts from S4, it cannot go to destination directly. It should take a round trip, go to S1 first, and then end up to the destination. Let's see how the agent is learning this task. So starting from S2, apparently agent could try going to S1 and then to SX, but since this path is not rewarded, then what we want the agent to learn is take a round trip, go to S1 and then go to the destination. Let's see what the agent has learned. For S2, it took the same path that as expected. For S4 and all other states, agent is behaving quite well. We can change this problem slightly and allow the access to destination from S5 as well. And then we can see how the agent is doing in that modified problem. So in this example, we can go to destination from S5 as well as from S1. Now we can see that all the states that are starting from S2, S3, S4, agent is taking this path, and then instead of going to S6, it is entering to the destination. However, it's for 2, 3, 4, and 5. However, for 6, 7, and 8, it will take the other path. After learning completes, how does the agent finds its way to the destination from any given state? The answer is very simple. Agent keeps the values of all possible actions in any given state in a table-like structure. Let's call it Q table. The Q table is shown to the right side of the tutorial under the rewards table. In Q table, the column heads represent the starting state where agent will start, and the row heads represent the next best state. So for our example of starting from state S4, let's look at the Q values in this column, and the best value we can get is 10.81. So this action take us from S4 to S5. When we end up in S5, the best value we can get from this column of actions is 10.9, which takes us to SX, the destination. After seeing quite a few of navigation problems, you must be curious how the agent is actually learning. If you have been constantly thinking about the Q values mentioned on the edge labels, then you are right on track. Let's find out how those values are calculated and how the agent is updating Q values in the next video. See you soon.